Hello dear students, in this lecture we are going to discuss about the next essential pre-uni physics, that is D5.3. Okay, now let me discuss first question. Consider a particle that is at a particular antinode of a standing wave, which we call point A. So we have a standing wave and a certain antinode that we call it at the point A. Fill in the blank below. So we have to answer these questions, that is beyond the next node along the point A but before the next antinode to point A. So let me draw the first the basically stationary wave. This is a stationary wave, kind of stationary wave, and two waves that is opposite, that are moving opposite, they form a stationary wave. The other wave is this way. Okay, this is the stationary wave. Okay, now the question asks us to, for example, we have an antinode, certain antinode, that is this point is A antinode, and he asks us beyond the next node, beyond the next node is here, this is the next node, from point A, but before the next antinode, so we know that the next antinode is this point, is antinode, next antinode. Okay, now as we know that before the next node and next antinode. Okay, now we have to find the amplitude compared to point A. So what is the amplitude compared to point A? So beyond the next node, we know that beyond the next node the amplitude is, you can see that here I draw the amplitude beyond the next node. So we have a point A and the next node is N. So beyond that node to before the next antinode, so we have these points, or you can say in either in this way, these points. So these points have amplitude. So amplitude is like mean from the equilibrium position. This central line is equilibrium position. The distance between equilibrium position to these points is always smaller than the amplitude A, is smaller than this amplitude A. You know that this amplitude is larger, this is a maximum distance. So these points have the smaller amplitude. So the amplitude part A, amplitude will be smaller. After the node, the next all the particles after the node have the smaller amplitude. Okay, now number B part, in the number B part, he asks we have to find the phase relationship at to point A. So in order to find the phase relationship between these 2 points, you can see that. So let me draw the figure again. For example, we have this kind of stationary wave again, and then there is another wave that is in this way, in this direction. So this is the stationary wave pattern. Okay, now we have this this point is A, that is antinode, and here next node is here N, and beyond that node to next antinode, all the particles are there. Then we have to find the phase relationship between A to these points after node to just before the next antinode. So the phase relation, as we know that these points is going downward, these points are going upward. So we know that this antinode is going downward. Okay, this antinode, specific antinode, is going downward. So if this node is going downward and these all particles after node are going upward, we know that the stationary wave is moving up and down. This antinode was these all points on the antinode, these are moving up and down, and these are also moving up and then going down. So these A point, at point A, the particle A moves downward, while all the other particles after the node, these all particles moving up. So they are moving opposite to one another. So it means they have the 180 phase difference. So the phase difference is 180. So always remember that if the any 2 points, so remember this formula, any two point separated by odd number of nodes, odd number of nodes, have 180 have phase difference, of 180, mean they are anti-phase. 180 anti-phase mean the phase difference of 180. Okay, so if they have the odd number of nodes, for example, you know that the between this A and these all points have the one node difference, because they are separated by one node, one n. So if also they are separated by 3 nodes, 5 nodes, 7 nodes, 9 nodes. So all these points have the 180 phase difference. And if they have even phase difference, for example, if these have no phase difference, 2 phase difference, 4 phase difference, 8 node difference. So when they are even node difference of even nodes, and they have they are in phase, but in this scenario we have odd number. They are separated by this A point, and these all points are separated by one node. There is a difference of one node, so it means they are separated by one node. The even odd number of nodes, so it means that they have phase difference of 180. Okay, thank you.